Welcome back to our series of lectures on vector differentiation for engineers. This is part 2 of this lecture series. In this part, we discuss partial derivatives with examples. Partial derivatives are the language of vector calculus. Without further delay, let us start the lecture.
Let us recall partial derivatives. Here, first we consider a function f from R2 to R. This function is a function of two variables. This function is also called a scalar field or a scalar point function. Because this function is a function of two variables, there are two partial derivatives. The first one is dou by dou x, and it is defined by the formula limit h tends to 0 f of x plus h comma y minus f of x comma y upon h. The second partial derivative is defined by dou f by dou y equals limit k tends to 0 f of x comma y plus k minus f of x comma y upon k. We know very well that while finding dou f by dou x, we allow x to vary and we treat y as a constant. Similarly, while finding the next partial derivative dou f by dou y, we treat x as a constant and allow y to vary. These two partial derivatives are derivatives in the direction of x-axis and in the direction of y-axis respectively. Here we consider the next case. We consider function from R3 to R. This is also a scalar field defined on the three-dimensional space. So there exist three types of partial derivatives: dou f by dou x, dou f by dou y, and dou f by dou z. The first partial derivative dou f by dou x is defined by limit h tends to 0 f of x plus h comma y comma z minus f of x comma y comma z upon h. The next partial derivative dou f by dou y is defined by the formula limit k tends to 0 f of x comma y plus k comma z minus f of x comma y comma z upon k. The last partial derivative is given by dou f by dou z equals limit delta tends to 0 f of x comma y comma z plus delta minus f of x comma y comma z upon delta. Why we consider these partial derivatives for functions of several variables? We see that functions of single variable, they have differentiation concept. But in the case of functions of several variables, we can't define the derivative as in the case of functions of a single variable. So here we have the concept of partial derivatives. Actually, dou f by dou x is a slope of the given surface in the x direction. Similarly, dou f by dou y and dou f by dou z represent the slope of the surface in the y direction and z direction respectively. Let us see an example here. I have taken a function f of x comma y equals tan inverse of x by y. For this function, let us find out these partial derivatives: dou f by dou x, dou f by dou y, dou square f by dou x square, dou square f by dou y square, and dou square f by dou x dou y. First, if we evaluate dou f by dou x by treating y as a constant and if we allow x to vary, then we get the answer y by x square plus y square. If I take dou f by dou y, we get minus x by x square plus y square for this particular function f of x comma y equals tan inverse of x by y. If we find out the second partial derivative dou square f by dou x square, that means dou by dou x of dou f by dou x, we get minus 2xy by x square plus y square whole square. If I find the next second partial derivative dou square f by dou y square, we get 2xy by x square plus y square whole square for this particular scalar field f of x comma y equals tan inverse of x by y in two variables. Lastly, if I find dou square f by dou x dou y, or if I find dou square f by dou y dou x, we get the same answer x square minus y square upon x square plus y square whole square. For this function, these two partial derivatives are equal. Here, dou f by dou x, dou f by dou y are called first partial derivatives of the given function. Dou square f by dou x square, dou square f by dou y square, dou square f by dou x dou y, and dou square f by dou y dou x are called second order partial derivatives. In this particular example, the last two partial derivatives dou square f by dou x dou y and dou square f by dou y dou x are equal. But for some functions, these two partial derivatives may not be equal. So, for some functions, we have to remember that dou square f by dou x dou y is not equal to dou square f by dou y dou x.
Part 3 is coming soon. Haven't you subscribed yet? Please do subscribe our channel. Thanks for watching.